Today we are going to talk about how to evaluate trigonometric functions with coterminal angles. We have two examples here. We'll focus on the first example right now. 17 pi over 6 radians. It does not look like it's in the unit circle. It's too big. The highest radians in our unit circle that involves a denominator of 6 is right here at 11 pi over 6 is the highest one. So we know definitely that 17 pi over 6 is too big. So clearly we got to take away something. So what we have to do is we have to take 17 pi over 6 and use our knowledge of coterminal angles. We can add or subtract as many 2 pi's, which is a full rotation, as necessary in order to achieve our goal, an angle that is somewhere inside the unit circle. So let's make this a fraction by putting 2 pi over 1. I cannot subtract this yet because I need a common denominator. So I need to multiply this by 6 over 6 in order to achieve a common denominator of 6. This has now become 17 pi over 6. Take away 12 pi over 6. And if you take that away, 17 pi, take away 12 pi, you're left with 5 pi over 6. So this means that the original question of cosine of 17 pi over 6 is exactly the same as the question of cosine of 5 pi over 6. Now we can go about solving this just like our previous lesson. We know that the ratio for cosine is x over r. We already know that the radius is always 1. So we just need to focus on figuring out the x coordinate. 5 pi over 6 is right here. The x coordinate is negative square root of 3 over 2. And that's why I will put negative square root of 3 over 2 for the x coordinate. When I divide them, I end up with negative square root of 3 over 2. And we are done. On the second example, we have another angle, and it's in the negatives. And clearly we do not have a negative angle in our unit circle. So we have to take this negative angle of negative 11 pi over 3. And we have to add a rotation because we want to get back to the positive side. So we can slowly add a rotation, even though I already know that 2 rotations is what it takes to get to the positive, but we'll just do it the long way. We have to put it over 1 in order to find a common denominator, which is 3. So I'll multiply this by 3 over 3 to get negative 11 pi over 3 plus 6 pi over 3. And that will give me negative 5 pi over 3. As you can see, we still have a negative angle. And that's why I said at the beginning, I know it takes more than 1 rotation for it to become a positive angle. So now I got to take this negative 5 pi over 3 and I have to add another 2 pi, which we can write as 6 pi over 3 because we already did that earlier. And that will give me 1 pi over 3. And we have finally achieved a positive radian. Therefore, this problem right here is exactly the same as sine of positive pi over 3. And the ratio for sine is y over r. We already know the radius is always 1 in the unit circle. The only question is, what is the y coordinate at pi over 3? As you can see at pi over 3 right here, the y coordinate is square root of 3 over 2. And that's why I'm going to put square root of 3 over 2 for the y. and dividing by 1, we get positive square root of 3 over 2. And that is the final answer to that problem.